I'm with the University of Nebraska-Lincoln. Freaky Units is a command line compiler time tool that performs dimensional analysis on ROS C++ files. Software has entered an age of action, from exploration to industry to future transportation. Software is the unavoidable link between sensing and actuation. All actuation and all sensing is expressed in terms of physical units: kilograms, meters, seconds, amperes, Kelvin, energy, force, torque. And it can be hard for developers to correctly manipulate this all the time. For example, in this code example, Freaky Units assumes that geometry messages pose position is a distance in meters. And this is calculating the distance between 2 points in R3. And the developers who are calculating the distance between the goal and the current position. The first line calculates x by multiplying the differences, and the next 2 lines, all 3 of those lines are on 1 line of code, incorrectly adds them. So this is adding meters squared to meters, which is physically meaningless. Another example, and a much more common thing that we catch with Freaky Units, is that people abuse the ROS API. If I download somebody else's code and I see a message of type twist, I'm expecting linear velocity and angular velocity, not positions in space. This tool does data flow analysis, and it's open source. You can use pip to install it. We also provide a virtual machine where you can download the whole thing and play with it. If you're willing to take a 10-minute game-style survey about physical units in code, please email me. If you're coming to IROS, there's a full talk on this Monday first session where we analyze this at scale, 3,500 repositories, about 5.9 million lines of code, and assess how frequently these kinds of inconsistencies occur. This tool won the best tool demonstration at ISTA, a software testing conference earlier this year. It has an 87% true positive rate, and it requires no programmer annotations. I have spoken.
Thank you, Mr. Jobs. All right, we've got Ross Underground by Tobias, thank you. And on deck is Sasha Shade. I hope I pronounced that right. Oh, you're up.
Hello. All right, we have seen ROS in space, we have seen ROS in the air, on land and on sea, but what's coming next, and where is ROS going next? And I'm Tobias from the Institute of Advanced Mining Technologies from RWTH Aachen in Germany, and that's where we are bringing ROS to, and that's yeah, there's like a whole mining industry that it's not that as bad as in the picture, but there's a lot of potential that we can feed with the ROS stuff and with development in that direction. And I would like to present you one of the projects we have, and that's an underground exploration vehicle that we want to solve the subjects with that everybody is fighting, the localization, the mapping, the whole stuff. And we do that by recording very dense point clouds from the environment that we use, or we want to use for surveying of mines, which we have very high legal standards, and also use those, put them in a data bank and extract maps from that for actual production vehicle localization and path planning and all that kind of stuff. And because we have very high standards, we of course need actual surveying equipment to reference our system, because we have very high, we have a very good positioning, and we integrated also a total station into ROS and making those things possible. And you know how it is with ROS, you're underground, all the guys are working, and all the good stuff is happening, and it's always the same, just like at home. Everybody's just staring at their screen when the good stuff is happening, and that's always how it is. And I would like to thank our partners for the work together that we have on that vehicle, and of course thank for the funding. And yeah, we are always looking for interesting partners to work with and to get new ideas going. And of course, as always on ROS, we are hiring and looking for new PhD students to work with us together and on projects like that. Thank you.
Thank you very much. Tully, I'd like to request that we start in ROS metrics, we start tracking maximum distance above and below sea level ROS is operating. All right, we've got HTC Vive with Sasha, and on deck is Richard Stanier. Yes, on deck is Richard, though.
No, it's Sasha.
Sasha's on deck?
Yeah.
Sasha's right now.
Okay.
Coming up is Richard Stanier, and I'm going to stop apologizing for mispronunciation of people's names.
Okay. Thank you. I just learned that everyone likes Arvis, and we do as well, and we like the HTC Vive and the VR headset. And so we just put both things together in the same project because we acquired lots of point clouds, and for debugging it's much more convenient to see your results on 3D instead of 2D in Arvis. So it is a HTC Vive fed by the Arvis plugin. You render two images for your right and left eye, and like this. And if this was a paper, yeah, it would be like this. I have to thank my fellow students for doing all the hard work, and I was just the head honcho to acquire that project. That's everything for you to take home. It's the link, and if you want to contact me, just go to LinkedIn, and that's all. Thanks for the funding of the UPNS 40+ project, and we are looking for some support in bringing this HTC Vive plugin to Arvis and make sure it's in the next or over next ROS release as well. Thank you.
Thank you very much. I look forward to seeing the reprise of that mining video, except everyone's also wearing the Vives on their faces. Okay, so coming up for everyone who's not reading over my shoulder. So we have Richard on deck, and coming up is Yiping Liu.
Hi everyone. My name's Richard Stanier. You got the pronunciation correct, it's pretty good. And I'm here to present or introduce you to a new robotic cloud platform called ROSCon. It's no relationship to OROCOS, that I now realise sounds a bit like a distant Irish cousin. Why are we building a new cloud platform for robotics? We really want to focus on the development experience, and we want to accelerate the rate at which all of you can bring solutions to the cloud and vice versa. We think that there's a massive opportunity in the cloud to open up the cloud to developers, especially roboticists, to have access to things like AI models, machine learning, really strong message buses, big data tool sets, all those sorts of things. And so we're developing ROSCon to suit those needs. There's a bit of boring stuff we'd like to take care of for you too. So if you're building any kind of robot solution that has access to the cloud or requires stuff in the cloud, we'll take care of the provisioning, we'll take care of the monitoring, alerting, and all those operational aspects which get in the way really of building really great robotic solutions. The beta we're taking sign-ups for, and will be available probably in a few months, I'd say. Really like to hear from all of you if you've got any specific challenges in robotics you think the cloud can solve. And please go to our website and sign up, and we look forward to bring you a new thing coming to a cloud near you.
Thank you very much. Can we run credit checks through that as well? Too soon? All right, so using MATLAB Simulink with ROS is what is right behind me. Oh, it's MathWorks.
Yeah.
Awesome. And Jesper Smith, you're on deck.
Hi, everyone. So my name is Yiping, and this is my cool colleague, Carlos. And we are engineers from MathWorks. We just want to show you guys how the MathWorks tools integrate with ROS. And I think many of you have been already very familiar with MATLAB and Simulink. And in fact, we also worked with robotics for many years and in many different application areas. As you can see, mobile robots, autonomous driving, and manipulators, UAVs, and we have also successfully worked with many customers in the automotive and aerospace industries on those robotics applications. And since 2015, we start to offer tight integration with ROS. And it's mainly through the Robotic System Toolbox, or RST. And we also, so right now in MATLAB or Simulink, you can have, we support live connection with ROS networks. And you can also generate code for standalone ROS node and automatically deploy them to the embedded targets. And as one of the latest features, and in Simulink, now you can use the so-called external mode to tune the generated ROS node in situ, and basically you can while the node is still running on the hardware. And this is the system diagram, and as you can see, the algorithm blocks are separated from the middleware blocks. So technically, you can very easily integrate your existing MATLAB or Simulink code with the ROS network. And just and of course, we are interested in ROS 2.0. And if you're interested in using ROS 2.0 with MathWorks tools, we'd love to hear from you. And Carlos and I will be here in ROSCon, and we also be in IROS. We have a booth in IROS, so just come talk to us.
And one more thing, today there's been a lot of interest on VMV, verification, validation, certification. We have a lot of experience. We work with a lot of customers in safety critical domains, right? So if you're interested, just talk to us. Okay, thank you.
So.
Thank you very much. And we'll be expecting your pull request to ROS 2 when? Soon, right, later. That's the answer. All right, there's someone ominously standing behind me. And next up, we have Zahi Kakish on deck, please.
Okay, I'm Jesper Smith. I'm from the Institute for Human Machine Cognition in Florida. And today I want to, why doesn't it go to the next slide? Introduce ITMC PubSub, which is our implementation in real-time Java of RTPS/ROS2 communication protocol. It's Apache 2.0 licensed, available on GitHub. So first, what does it do? It's a lightweight wrapper currently around fast RTPS. Lots of care is taken to not allocate any memory when sending and receiving objects, so we can use it in a real-time environment. Object-oriented, based on the fast RTPS API, and could provide other backends like JRTPS or RTI later. Big thing is native Java IDL compiler. Goes straight from IDL to Java code. Every element is pre-allocated, even strings. And there's no C++ code you have to compile, so you don't have to go through that step. Also can export data to YAML for long-term storage, and then when you change your message, you can still read the old fields. And then we have an RTPS visualizer for debugging, and that's in alpha quality. So this is a picture of what kind of view we get over our network using our tools. So why did we choose a custom Java implementation instead of using any of the open source implementations that have some Java bindings? So we really cared about using our real-time safety, so we couldn't allocate any objects, and any Java code that you download off the internet likes to allocate lots of objects. We also didn't want to make a C++ wrapper of every IDL message we write and then go to Java. We also have abstract implementations, so you can compile an IDL to like an abstract version, so you can reuse existing data types like a vector or a point or whatever you made, and then have it backed by the IDL without having to copy the data. So first results, and this is also our internal test of fast RTPS. We have a logger that does 10,000 variables that are 64 bits a piece at 1 kilohertz, sends it over RTPS best over, and drops maybe like a few packets a minute. What we learned, do not use the fast RTPS write or publish methods directly from a real-time thread. It's a blocking call, and you really want to not deal with that. You get 3 millisecond spikes in your real-time loops. And what's really cool is the history. So when you switch over, you should definitely do that. And that's it. You're laughing at me?
Thank you very much. You look kind of nervous there. When do we get the Megabots robot in Gazebo, by the way? Can we have that pull request? All right, awesome. Peer pressure. All right, and on deck is Dave Coleman. And right now we have final low-cost Pheno.
All right, everyone, my name is Zahi Kakish, and I'm from Arizona State University, from the Autonomous Collective Systems Laboratory under Dr. Spring Berman. And today I'm going to talk to you guys about Pheno, a low-cost, ROS-compatible swarm robotics platform. And if many of you don't know, we essentially create algorithms for multi-agent systems. And one of the difficulties of doing multi-agent systems is that the simulation data that we have doesn't really work in the physical system. So trying to map our algorithms onto physical systems is difficult, and it's pricey, and we need options that will scale well and are modular. So that's why we invented Pheno. So Pheno is a low-cost platform. It's about $260 to make. It is open hardware, so the PCB and the STL files are available for everyone to use. It has a gyro, accelerometer, magnetometer, IR sensors, encoders, everything you could want in it, and many lanes for people to actually add stuff to it. The brains of the operation on this is a Raspberry Pi 3 and a Teensy microcontroller, which is essentially just a regular Arduino if it decided steroids were a good idea. So here we have the Pheno, as you can see at the top right, different modules that we've created for it. We have a omnidirectional wheels for holonomic motion. We have the normal differential drive robot, and we have treads for outdoor usage. And the other scene, the bottom left one, is a demonstration of 30 of them running ROS in an obstacle avoidance scenario. So, and the final one is we're starting to use ROS in creating miniature autonomous vehicle test beds, so people that do have big scale algorithms can scale them down to our Pheno to use. And if you would like to know more about the system, we have a paper in Robotics and Automation's letter for anyone who wishes to learn more about the system. And I'd like to thank everyone here, especially our sponsors, the NSF, DARPA, and the ONR. And for anyone who wants to contribute to the project or learn more about the project, acslaboratory.github.io. Please also feel free to contact me as well if you want to just talk to me here. I'll be here the whole time. Thank you, guys.
Thank you very much. I approve of the ominous lights. You run those in the dark? Yeah. Awesome. All right, behind me. Yep, behind me is talking about World Move It Day, and then next up we have John Morris. Sorry, that's Dave Coleman talking about World Move It Day.
World Move It Day, Part 2. So last year, Michael Ferguson from Fetch came to me and suggested, hey, let's have a World Move It Day. So we did. It was great. And we accomplished a lot last year. It was really exciting results. We had a total of 27 participants, a bunch of locations around the world, namely one at Fetch, one at Examla. In total, we closed 65 pull requests. We had 10 that were started in progress after that day, 21 issues were closed, and in total, 28 GitHub users contributed. So really successful event. We're doing it again. Please join us on October 18th. We already have several locations lined up. Verb Surgical is this robotic surgery company in the Bay Area. 2 locations in Germany, Bos Magazino and Examla, and also the Southwest Research Institute's having a location. I also just got word that Shadow Robot will have some location in London. May or may not be open to the public. But if you want to add yourself, please do contact me. There's also a sign-up form. And overall, the day will be, you can learn the tutorials or have contribute to the documentation, bug fixes, adding new features, whatever level you're at with Move It, please join us from whatever location you're at. You can video conference in. It'll be a fun day. Most locations have free food. We'll have free stickers. Yeah. Second thing I wanted to pitch real quick is, we've been trying to get together some code sprints for Move It, and the first one we want to tackle is this minimum cycle time motion planning for bin picking. So I've been talking to some research groups, different professors who all want to have a benchmark data set where if you have a manipulation or motion planner, you can compare it against the same tasks that these 3D robots will be doing. And they want to have their first implementation be in Move It, which is really exciting for us. And so if you're interested in sponsoring this, we want to run this benchmark across different planners, create a report, and kind of improve Move It's functionality in this particular application set. So please reach out to me if that's of interest to your company, maybe a project in collaboration with the ROS Industrial Consortium. Thank you.
Thank you very much, Dave. You had me at free food. All right, we've got John Morris talking about the Vancouver ROS Users Group, and then coming up after that is Max Matsushima.
Good afternoon. I just want to ask one question first. How many people in the room are live or work in the Greater Vancouver Lower Mainland? Oh, quite a good chunk. Well, you might want to know that there actually is a Vancouver ROS users group. It got started last year, and we've had topics such as introduction to robot simulators, building intelligent apps with cognitive services, drones big and small, applications of computer vision, robot mapping using SLAM. If you're interested in joining that group, we use a platform, a meetup platform, and just do a search on the robotics Vancouver ROS users group, and you'll find more information there. In October, we are having a sensor show and tell, and hopefully you get your hands on some sensors and learn a little bit from the presenters. So thank you very much.
So the free food answer? Free food. All right. On deck or behind me right now is the ROS 2 implementation on an MCU given by Max, and on deck is Julius Gelsvartis.
Hello everyone. My name is Max Matsushima from Renesas Electronics. the world-leading MCU company like that. And today, I'd like to announce that we are going to support ROS. And to begin with, we are working on native support for ROS 2 on our MCUs. Here is a demonstration we are working on right now. And there are two ROS nodes, sensor node with joystick and actuator node with a punch tilt unit. So sensor node sends position information to actuator node by using RTPS. So as you move your joystick, Godzilla moves in response like that. Okay, this is a board I use for this demonstration. The MCU on this board is Renesas RX MCU, which runs 96 megahertz and with 1 megabyte of flash and 256 kilobyte of RAM. This is not like a full-blown microprocessor like a Raspberry Pi. Instead, this is like lightweight MCU intended just for embedded applications. But still, we are able to run it, RTPS run it on this processor. So this is the architecture overview. We implemented these three software layers. There is an abstraction layer top of a Renesas native software, and the FreeRTOS runs on it. And the application runs at the top of the stack. So as you can see on the right-hand side, we can fit even this tiny memory space and still have room to spare for other applications. Oh, by the way, I'm planning to upload these three software as open source on the GitHub pretty soon. So what's next? We can do many things, but our focus right now is on two things. One is ROS 2 under FreeRTOS using LWIP stack, which is true open platform you guys can use, and also try to expand support to other Renesas MCUs if you guys give us big thumbs up on this. Thank you very much.
Thank you. The 60 kilobytes is impressive. Can you rewrite some printer drivers for me, please? No. That was too much to ask. All right, standing behind me, I'm sorry, I can't, Rubedos Sistemos. And on deck, we have Sheep Bai. Oh, video.
My name is Julius Gelshortas, and today I want to present a stereo vision camera that my company, Rubedos Sistemos, is developing. So the camera has an NVIDIA TX2 on board, and for doing the stereo matching and stereo processing. It's running ROS internally, so it's really easy to use it in your applications. And there is some computing that's available on the TX2 that you can use for running your own software. The camera basically has, as any other stereo vision camera, it's two cameras. We are planning to have the camera ready to sell in the beginning of next year. But if you are interested, we are planning of shipping prototype versions of the camera for early adopters soon. So if you are interested, please contact us. Thank you.
Thank you very much. I notice your extras were instructed to just shake hands vigorously. Practicing for trips to America. All right, so we've got a discussion about the Stevens Institute of Technology by Shibai, and coming up afterwards on deck is Jeff Biggs. Oh, that's actually a presentation. Is the presentation public?
Good afternoon, everyone. My name is Shibai. I'm from Mechanical Engineering Department of Stevens, majoring in robotics. We do a lot of robotic stuff. And during this summer, we actually had a discussion between the group members and our boss about what type of sensor, especially 3D LiDARs, we're going to get given the budget we have. We came up with the conclusion that the 3D LiDAR sensor is a little bit expensive. Not only expensive, but also even you go with the very high-end, for example, the Volondyne 64 scanline version, it's not giving you wide enough field of view vertically. So we decided to build 3D LiDAR ourselves with 2D plenary LiDAR attached to a servo motor. So here's the setup. We have it on one of our ground robots. We also have a 3D LiDAR there taking care of the localization as well as onboard router. So the idea is pretty straightforward. We publish the transformation between the servo frame to the laser frame, and then we use the ROS library laser assembler to assemble those scans. This is a short demo of really straightforward, simple indoor environments. We also went for a few more complicated scenarios. Like this is the Liberty Science Center in New Jersey. This is a short video of how it performs indoor. It's optimal map we built online. There are actually two modes. One is a single sweep that you can publish empty message to a specific topic, and it will do only one sweep for you. Or you can launch the continuous mode launch file, which will spinning continuously, and while the robot moving is going to generate a map of the environments. Is there a way I can? Yeah, given the time constraint, I will just fast forward this video. So all these indoor localization is taken care of by the G-mapping package. Yeah.
Thank you very much. There had to be one. Also, 3D LiDARs are a bit expensive. You are the master of understatement. I was a bit tired this morning. Okay, so we have Jeff Biggs talking about AIST, and on deck we have Ryosuke Tajima.
Okay, good afternoon, everyone. I'm Jeff Biggs from AIST, and I'm not actually going to be talking about AIST. I'm going to be talking about the problem of orphaned packages. So there's a problem in ROS, which is that the number of orphan packages keeps going up. Usually this is problems like the maintainer is too busy to respond, or they've moved on. A lot of packages are produced by PhD students, for example, and they go off and get a job and they forget they had a package to maintain. Maybe they got rich or something. And these packages, they don't get released in the latest ROS distro. Sometimes this is because they just don't work. You know, the APIs have changed, they won't compile anymore, but sometimes they actually do work just fine, but they're still not released. And so the only way you can use them is by compiling the source. Particularly notable examples of this, the USB camera drivers weren't released in Kinetic for a year after Kinetic was released, even though Kinetic is an LTS distro, which is kind of shocking, I think. I'm pretty sure USB camera is a fairly common thing to use. There are 90 unreleased repositories for Kinetic when I checked this morning, and 366 for Luna. Granted, maybe not all of these compile, but I did do a check on blockers, and only half of those had no blockers to actually being released. And so Luna's pretty new, but you know, Kinetic's been out for quite a while now, and still having 90 unreleased repositories is a bit sad, I think. But you know, there's no real easy solution to this problem. I mean, the ideal solution is you find a new maintainer. Someone comes along and says, hey, I'll fix that, and I'll keep maintaining it, which is great, but it's pretty easier said than done, because usually no one bothers to volunteer. You know, no one wants to do that. It's hard work, and you have to keep looking at bugs and fixing them, and you don't get to do any fun stuff. So does that mean these should disappear? I mean, I don't think it does, because things like USB camera drivers are fairly commonly used, and we don't really want those to go away. So there's a group in Japan which has come up with a proposed practical solution, which is a volunteer group who will maintain orphaned packages. And their goal is to do this with minimum effort, which means that they're not going to investigate incoming issues and do pull requests and so on. You know, if the package breaks, that's it. But they will release the repository into the ROS ecosystem as long as it keeps on working and running Room and so on. So they've already released several unmaintained packages. Again, the USB camera drivers are notable, but there's some other ones that they want to use on their robots, which they've released. And they're preparing a ROS extension proposal for a ROS Orphan Package Maintainer initiative to define the process for how this works. And they're calling for contributions. So, you know, if you're interested in helping out just as part of a group, you know, you don't have to keep maintaining the package all the time yourself. You know, just when you have time, you pull a package off the list and you do a bit of work on it and then throw it back on the list again. Join them. And they have some funding from the Japanese government to work on this, which is going to get them to keep going. So if you're interested, please come and talk to us, and maybe we can try and get a few of these packages released. Thank you.
Thank you. Jeff, funding includes free food? Okay, excellent. 3 for 3. All right, up next we have Torque with Ryosuke Tajima, and then our last lightning talk will be Bill Kuhn.
Thank you. I'm Ryosuke Tajima from Torque, Tokyo Open Source Robotics Association in Japan. Today I'd like to present our 2 packages recently we released to Indigo and Kinetic. The first one is Industrial Manipulator, TRA. It is designed by Techno21 company, and it is a standard articulated robot manipulator, but it is very powerful and very easy to arrange its design thanks to it is consists of EtherCAT drivers. You know, the EtherCAT is very popular in factory automation right now. So we wrote a driver for the EtherCAT drivers, and we can make it very simple, and we can use it with MoveIt high-level controller. And we are now released Indigo, and the source code is available here, and video is online on our website. So please consult with them. And the next package is Roomblock. We built the robot based on the Roomba, and it is a cheap platform for learning ROS navigation. You know, it consists of Roomba and Raspberry Pi, RP Rider, and mobile battery all are available on the market, and the 3D printed frame is available from ThinkBus, so you can download the data from the ThinkBus. All instruction is on instructable site, and the video is available on our website. So why not use Turtlebot? Yeah, you can choose you can choose the robot, but believe me, my wife gets angry if I buy Turtlebot with my family budget. And yeah, Roomba, I don't know why, but Roomba is okay because it cleans our room, so everyone is happy. It is a win-win solution, you know. So we can use this platform for benchmarking the loss mapping and SLAM packages like Gmapping or SLAM Carto or Google Cartographer like this. And we are doing some seminar with this platform in Japan, and we can teach the student or some people about loss navigation, ordinary loss navigation stack with this platform. If you are interested in this platform, please consult with the website and build it by yourself. Thank you.
Thank you. Buying robots that do household chores, that's perfect. All right, last we have GeoFrenzy, presented by Bill Kuhn. Uh-oh, oh, there we go.
The GeoFrenzy ROS package, under development by Road and Arrows Robotics, allows UAV developers to easily integrate the functionality of the Fence Delivery Network into their applications. The Fence Delivery Network, developed by GeoNetwork, is a set of virtual fences associated with rules that are aimed primarily towards UAVs. The fences are stored on the cloud and delivered dynamically to clients, which can autonomously react to geospatial regulations. The GeoFrenzy web portal allows users to configure and set up these fences. For instance, a residential property owner might set up a fence over their yard that doesn't allow UAVs to use downward-facing cameras when flying over their property. The package we've developed makes interfacing with these fences an easy task. The GeoFrenzy server node subscribes to a NavSat fixed message, queries the network, and then publishes any relevant information. We also have helper nodes. Such as a virtual cloud node that publishes a point cloud representation of the fences that can be used in a navigation stack. We have a sensor relay node that can be configured to monitor specific topics like camera permissions. And these relevant information can be relayed to the corresponding subsystems. We have an alpha version currently available on GitHub. We plan on releasing a beta version in the near future. For any questions, you can direct them to Road and Arrows Robotics. And of course, feel free to chat with myself or my colleague, Kim Wheeler, for any more information. Thank you for your time.
Thank you very much. I think that's actually the most compelling reason to learn ROS. If you learn ROS, you can keep your neighbor's drones from flying over your house. All right, that, believe it or not, we just made it through 15 presentations in about 40 minutes. I'd like us all to give the presenters again a round of applause.